Active filters. The magnitude of the filter M is called as the gain of the filter. Magnitude is generally represented in dB as 20 log M. One of the important characteristic of the filters is cut-off frequency. It is defined as the frequency which separates both passband and stopband in frequency response. Passband is the range of frequencies that are allowed by the filter without any attenuation. Stopband is defined as the band of frequencies that are not allowed by the filter. Filters are classified based on the frequency of signals that they allowing through them. There are 4 types of filters. They are low-pass filters, band-pass filters, high-pass filters and band-stop filters. Due to the usage of high-speed op-amps and approximate values of the components, the characteristics of ideal and practical responses are nearly equal. Low-pass filter. Low-pass filters will pass the frequency signals less than cut-off frequency Fc. Practically a small range of frequencies will pass even after the cut-off frequency range. The gain of the filter will depend upon the frequency. If the input signal frequency increases, then gain of the filter decreases. At the end of the transition band, the gain becomes 0. This is as shown below, where dotted line indicates the ideal filter characteristics and continuous line indicates practical filter characteristics. Applications of low-pass filters are in sound system, that is in various types of loudspeakers. To block the harmonic emissions, these low-pass filters are used in radio transmitters. These are also used at DSL splitters in telephone subscriber lines. High-pass filter. They will pass the frequencies after the cut-off frequency Fc. In practical case, a negligible frequencies below the cut-off range is allowed by the filter. This is as shown below. The combination of high-pass filter with low-pass filter forms band-pass filter. Applications of the high-pass filters are at RF circuits and are also used in DSL splitters. Band-pass filter. The name of the filter itself indicates that it allows only a certain band of frequencies and blocks all the remaining frequencies. The upper and lower limits of the band-pass filter depend on the filter design. Practical and ideal characteristics of band-pass filter are shown below. Applications of band-pass filters are at transmitter and receiver circuits. These are mainly used to calculate the sensitivity of the receiver circuits and to optimize the signal-to-noise ratio. Band stop filter. These are also called as band rejection or band elimination filters. These filters stop only a particular band of frequencies and allow all other frequencies. The frequency limits of the filter depend on the filter design. The dotted line indicates the ideal case, whereas a continuous line indicates the practical case. It has 2 pass bands and 1 stop band. Applications of band stop filters are at instrument amplifiers.